innovation that occurs in one city will spread to the other one. And what's one of the key forces at hand that cause that sharing, if you will, of the benefit of the innovation?
Knowledge spills.
The knowledge spills, okay? And what else? Between two cities, one city has something good happen to it, ultimately that gets shared. What was the other thing that we kind of need to have into the equation to get both cities benefiting? The migration, right? So the migration from one city to the next. So oftentimes economists talk about this. You've seen this in other classes where we need flexibility of resources to move to different spots. And so one of the neat things about this topic, spatial economics and urban and regional economics, is we look at the immobility of a resource, like land, and what sort of issues that brings up. Okay, so we left off, let's see, right here, looking at this multiplier. So, on the multiplier, my cameraman here, so just want to catch this little bit of board space. There we go. So how does export employment multiply employment? Export employment multiply employment, total employment. So you bring in 1,000 jobs, employment goes up by 1,000. But they're saying there's this multiplying concept going on. What was the deal there?
There's more people in the city making the export product.
Okay.
So there's more money to spend locally.
Okay, so their paychecks come in from money sold to foreigners, if you will, but really we're talking about our city versus maybe other cities in the United States. So their paychecks come in, the revenue that they sell, if the resources that are used in that particular job are all local resources, labor being an important part of that, and those paychecks end up getting spent on haircuts, pizza places, and local places. So it ends up increasing the demand for local employment as well. So that's the multiplier effect. Michael, looks like you're going to lose it. A couple nerds down.
I thought you were about to say points, and I was like, what did I do?
No. You're fine so far.
I thought so too. My cell phone's in my back pocket.
So here are some multipliers that were estimated. I should have cited the source. Oh, here it is. Yeah, that's right. This Northwest, I don't know what economist did it. And so it's got industry by industry, this multiplier concept. Export goods, and then there's this multiplying effect. So my big question that I want to noodle first was, why do they vary by industry? So these are all industries that are in the same city, or think about that they're in the same locality. Why would the multiplier vary?
Based on the number of jobs it brings.
Okay.
Like, you bring in more jobs, and it's going to bring in more money, and it'll have a higher multiplier on the local employment based on the export industry.
Okay. So let's try to separate the jobs and the money. What's driving it? So is it the job or is it the money?
Could be on the wage that the different jobs like offer to.
That would seem to make an impact, right? I mean, if you added a $20,000 a year job or a $100,000 a year job, that person who gets hired for that job has a lot more disposable income to spend in your local community, right? So that could be, that's got to play into that somewhere. So some of that variation would be picked up here by analyzing the types of industries. Okay. What else? Look at the high ones, look at the low ones. So the highest one up here, the winery. We've got photography, we've got optical instrument and lens manufacturing, computer design systems, computer programming services. We got this concept of an export job supporting local jobs. Because a part of this doesn't make sense to me. Like if you take a job and you're getting the same $20,000 paycheck, then that $20,000 is still getting spent by the average person within their community. And why does it matter if they work here or they work here?
How do you know the wages are the same? Like, you don't know what the wages are.
We don't know. That's right. We don't know. But this is what the multiplier is a job analysis. So one of these jobs supports another job. We're not actually into the dollars yet, but I was trying to
Wait,
kind
is
of
the
think
multiplier
about that.
specifically one local job supports? Like, where is it?
It's one export
No, it's the
job.
export job.
So, wouldn't it mean that two export jobs support one of those?
One export job adds more to total employment. If we bring in one export job, then we add. So if the multiplier, I'm going to do it on the next slide here, but here, if we bring in one software publisher job, employment goes up by 2.17. So that one software job creates 1.17 local jobs. So it is a job effect, is what the multiplier is honing in on. So we can start to think about each industry having a mix of local and export, right? In reality, it's not black and white, probably. This software publisher is selling, if it's a big city like Kansas City or something, is selling some of their product to the locals, and then maybe some of it, maybe it's 80% is being sold to other, while 20% is being sold local. So that's one thing that I had to think as I looked at this to think, why are these even varying in the first place? And so if your business has a bigger fraction, getting to this question, a bigger fraction of export sales relative to local sales leads to greater, right? So more export sales as a fraction of your total sales would lead to a bigger multiplier. And so perhaps that's what this number's picking up here, is how much of the mix each of these industries make up. Katie?
And then like it says a 1 unit increase in export employment increases the local jobs. Like I guess I just don't understand what that.
So this is picking up the total effect.
Uh-huh.
So the multiplier is
Part
2.49. And so if we bring in one insurance carrier job, they're going to generate 1.49 local jobs.
Okay.
So the total employment, if we bring in a new industry that is that type of industry, this is predicting that it'll add to total employment 2.49. So if you're a city looking to attract new businesses, and an economist did this type of analysis, and you're already going down the road of trying to decide what type of industry to maybe offer some special incentives, which we're going to talk about later today, which one do we want to hit? The one with the higher multiplier or lower? The higher, right? So try to get more of that local action, as much of that as we can. All right, so I think I do the interpretation here. This particular area, all of these numbers average out to be over 420, well, I didn't put that in, I meant to, 420 some industries is 2.1. And so on average, if we bring in a new company within all of these industries, if we had a random draw, if you want to think of it that way, we get the total employment increasing by 2.13, or every export job supports a local job. So 1 plus 1.13 equals 2.13. Okay?
What do you exactly mean by an export job? Like just people working at export products?
Who wants to tackle that? You do need to know that kind of off the top of your head.
What is an export job?
It's a job in an industry where you're producing something that's sold to people outside of your city.
Okay, so
Outside
you're
the
saying-
city.
So if you, like say Michael is exporting products, him having an exporting job is supporting 1.13 other local jobs?
Yes. Yep.
I guess I'm just confused.
So
on
if we've
how-
got our city here, and in the city we make our Mountain Dew, and we sell what I was kind of arguing before, as if this is our Mountain Dew bottle. Looks like somebody giving the middle finger or something here, I think. But if this is our Mountain Dew, we're going to sell 80% of our Mountain Dew to people outside of our city, and 20% of it's going to be sold to people inside our city. This is the idea of exporting the goods that were made here. All of the revenue for the company, 100% of the revenue for the company stays in our city, potentially. We can start to get into leakage issues of now, if somebody in Gardner works for Ottawa University and travels in, they get their paycheck and the money leaks out. I'm bringing up other topics that maybe I shouldn't right now, but those are some competing issues that go in with the industry. But in this model, if we and that leakage component could be picking up some of these numbers when you do an actual study as well. But that's your exports. So it's product that's sold outside of your city.
Yeah, okay, I understand that part, but I'm just saying, I guess I just don't understand how an export job makes local jobs.
Oh, okay.
Like the wage that person's getting in an export job is being spent on local goods.
Which
And so that gives them
leads
the
to
demand.
more employment.
Yeah.
So if you earn $40,000 a year as your paycheck working for this company, and they sell this product, exporting and local, that $40,000 stays here. You buy a house, you run to Walmart, you run to Applebee's, you spend your money locally.
So you're saying that when you have a lot of exports, that revenue is coming back and creating jobs for other
Yeah.
people?
Now this is very similar to the multiplier process that we looked at in macroeconomics, right? The spending multiplier, the Keynesian concept of money multiplying into other money. But I want to be clear here, this is not talking about money, is it? When I put these little arrows out of Walmart and Applebee's and other things, what is it creating? Employment. It's employing jobs. The concept is similar, that you're spending your $40,000 paycheck, but that just means that you're assisting in creating a job for somebody else at Applebee's to
Okay.
wait on tables and to clean dishes and whatever.
Which by default kind of increases local money.
It does, yeah. They're related concepts. I just want to make sure that this particular thing is a job multiplier concept, not money. But they are close akin to each other. Okay, so graphically, we can think about this maybe in this respect. We've got this demand curve. I did bring my club. Good. I have my visual effects when they come into play. All right, so a new export industry comes into town, and they need to have 10,000 workers. If our multiplier is 2.1, that leads to 11,000 more local jobs. So this is the extra multiplier effect. Holding constant this wage, that is the predicted increase in employment. All right, so that's a graphical depiction of what we're doing. let's think about supply. So we started off last time with defining the demand, the urban demand curve, and then we defined the shifters, and then we looked at that multiplier, and now we got the supply curve. So along a stationary supply curve, these are households deciding to enter the labor market at different wages. Increase in wages in one area with this topic in this class, we kind of want to start thinking about that migration issue, that it's going to attract people. And so the supply in one city might decline, whereas the supply in another city would start to go up. Okay, so now we're going to talk a little bit about elasticities. And these might be kind of some weird elasticities. We can really calculate elasticities for just about anything. So, who's up for an interpretation? The elasticity of living cost to the labor force. 0.2.
So, for every, I guess, unit change in the size of labor force, the living cost goes up proportionately.
Okay.
20% as much.
By 20%. All right. Does everybody agree with that? You weren't quite on with it. You're close. You got the right concept.
And 7%.
Okay, and that's important to get what the sizes are. So what does this look like? Elasticity of, let's go back to good old principles of economics. Elasticity of demand is, yeah, something change. What is it? Percentage change in, yeah, price on top or price on bottom? Quantity over price. Income elasticity is quantity over income. So usually whatever we called it was the thing that was on the bottom driving it. Okay, and that's important to remember here because we're doing the same thing. With this example, we've got the elasticity of the change in the labor force. So we've got the living cost and the labor force being 0.2. And so with every elasticity, so let's go living cost to labor force, just to kind of follow their notation here. We got 0.2. What can we do with any number to express it as a fraction? I got something easier.
1 over
Yeah,
100 over.
so how do we make this number,
Multiply by 100.
and you can pick any number. How do I make this a fraction? The number 3.
Multiply by 1 over 1.
1 over 1, right? So 3 over 1. We can put any number over 1. We can put any number over 10 potentially if we do some manipulation. So this is where the interpretation kind of pops out at you. If you remember that trick. A 1% change in the labor force leads to a 0.2% change in living costs. Or a 10% change in the labor force leads to a 2% change in living costs. Chelsea, did you have a question? Okay. All right, so remember that with elasticities, that little trick is kind of the thing that gives you the interpretation each time, to give you some intuition. Now this one, notice they did kind of a little inversion thing. You guys are bringing up inverting. All they did is flip the two variables around and thought about one driving the other. So that's another thing that could be done. Okay. So elasticities.
Just a real quick thing.
Yeah.
2% change, 10% change in labor. Okay, living costs, and then it changes the labor force. So the labor force is, okay.
With this,
That's one.
yeah, this is the second thing, so it's on the bottom. So this would be percent change in living cost over the percentage change in labor force. And so then we've got a 10% change in this guy leads to a 2% change in that guy.
Okay.
Labor force grows by 10%, the cost of living goes up by 2%.
So are these elasticities like constant elasticities across every city and?
No, it could potentially vary, so it depends on what your study
I just
is.
didn't know, 'cause like they didn't, like when they went over this, they didn't give us any like examples they're talking about, but they have set numbers, so I just know these numbers.
I couldn't remember if this followed with that Northwest example or not, but you're right. I don't think they gave us the area, but they do give us the citation in the back of the chapter. But to answer your question, it's whatever area they looked at in the study, because they're going to enter in a bunch of data that they collected about a particular city, and then they're going to run regressions and do some econometrics, and then out pops these numbers for the elasticity. So I am not sure what area they covered there. Okay. So what causes the labor supply curve to shift? Amenities, yes. What else? Disamenities. What would that cause?
Something that decreases the attractiveness. Like, if you have pollution or something that people don't like.
So in order to get it to shift to the right, you'd have to do what to that?
Reduce
Get rid of it, right? So reduce that. Okay, good. So with the city, we're just thinking of things that make it attractive. What things would make it attractive? And that would cause people to start to locate there. Notice that these are things that are attractive besides the wage. The wage is a movement along the curve. As the wage goes up, then people will migrate to the city, but that's not a shift, right? Because that is on the vertical axis. So when other things in our city start to look better and we enjoy some of the infrastructure more, the thing that's hard to divorce ourselves with here is what? Have you been to some really nice cities that have some cool stuff? I mean, if you go into Olathe, what do you see when you're traveling up 35 to Olathe? What's the first thing you hit, or roughly the first thing you hit? The welcome to Olathe. What does that sign look like?
It's really nice.
Super nice, isn't it? Like all stone, and they got, beautiful landscaping around it, big
Lighted
shiny
at night.
silver. It's lit, it's backlit at night, and it's like, oh, okay. This is a ritzy area or something here. That's not the way my town has their signage, right? Now, that's a nice part. That would cause you to maybe want to live there. But the part that's hard to divorce yourself with is what? What also might run through your mind when you look at that sign? That tax dollars are high, right? Oh, that money's got to come from somewhere. My city certainly couldn't afford that. I wonder what the property taxes are here, right? So that's the trade-off, and for economic modeling purposes, we kind of have to try to divorce ourselves from that and to say, let's have a nicer sign without it costing any more. What would be the effects of that, right? Which in some ways doesn't make sense, but that's what we have to do because the interaction of the two is equilibrium concepts, and that's what we're trying to predict. Okay, so there's some shifters. This graph is showing that increase in demand that we had before that had the multiplier, and now I guess my little arrow here got too cutesy and covered it up. But we went from 100 to 121. So that was the multiplier effect from the demand of an exporting company coming in. Multiplier was 2.1. That was holding constant at this wage. In reality, we've got an upward sloping labor supply curve, and that's going to cause us to not get out to that full multiplier. It's going to stop short because wages are going to start to go up in the meantime. So we need to try to grapple with how to make a better prediction, knowing that there's multiple things going on, that it's not just as easy as having this simple job multiplier moving out. Why does the slope matter? The intersection. So what is the slope related to? The slope of the elasticity. So we got the elasticity of supply and the elasticity of demand playing a role here. If we have a more inelastic supply curve in the face of this increase in demand, we get a different result. Right? We don't get as much employment. We don't, that multiplier effect in equilibrium is a lot smaller than what it used to be, and there's a larger wage effect. So we need to work on the interrelationship of that. And it's the supply relative to demand. If you remember back to the impact of a tax, we had the relative elasticities mattering to how much deadweight loss there would be with a tax, right? So one relative to the other. If we just made one steeper and left the other one fixed, it had an impact, but we could go back to having the same effect by making the other one steeper. So it was how steep one was relative to the other. Making it a little fancier, it was how elastic one is relative to the other. So we have a formula to try to capture that interaction of the two. And this is the formula that has kind of a long proof of showing how the elasticities drive that result. And you don't need to know the proof. It would take me a while to derive it. I did it another time a while back. But so the percentage change, you can come in for office hours and we can see if we can put it together.
Can we use golf clubs?
Perhaps. So equilibrium change in the wage is the first effect that we're going to look at, this 3% jump. What is that one going to do? So the formula is to add the elasticities together. It's the fraction of the elasticities, so it's the ratio of the two. Elasticity of demand in absolute value. Remember that it's always negative, so that's another thing here. This is in absolute value. Add it together, and you can start to dissect these two effects. The multiplier told us 21%, right? The 2.1. We went from 100, and the multiplier was 2.1. So we get a 21% change in demand from the multiplier formula. The elasticity of demand and supply, just using the numbers that we had before, grand total of 7. 21 divided by 7, 3%. So this is just kind of a neat little breakdown of dissecting the effect on equilibrium wage between supply and demand, without having to graph it out and look at it, right? So if you have a problem where you've got the elasticities that were estimated in a study, now you can put this in and report it to your boss that you think the equilibrium wage is going to go up by this amount. All right, questions on that one at all? the last step is the quantity. The first steps down to here was to get this effect. Then we backdoor it into the elasticity of supply formula, because all we're doing is we're moving from point I up to point N to calculate the 15% change down here on quantity. So again, we didn't know these ahead of time, remember. So we're really, if we're focusing in on the formulas, we're starting here and ending here and predicting that there'll be a 15% increase in labor in this market. All right. I think we might be ready for a change of pace. Let's do a problem. We'll come back to the kinky part. I'll just hold you in suspense. This is 5-5. So do problem 5-5.
What?
So the city of Groville, the equilibrium employment's 100,000. The equilibrium wage is $100 a day. The elasticity of demand for labor is 1 in absolute value, and the elasticity of supply is 5. The employment multiplier is a 2. Suppose the demand for labor used in production of exports increases by 6,000 jobs. Using a supply-demand graph of the urban labor market to show the effects of the increase in the demand for labor. What happens to the equilibrium wage? What happens to the equilibrium level of employment? We'll see if you were paying attention. Basically follow right what we just did. initial equilibrium, and then part B wants to know what the new equilibrium wage will be
Okay.
after the demand shift.
But part C is asking from the movement from disequilibrium.
No, we never get here.
Okay.
Yeah. So that, and that's part of
Gotcha.
it helps to identify how far the shift is. There you go. What's that number? Okay.
I understand what the increase in the need is,
Mhm.
but, and then I did the increase in supply behind it, because we don't know that number is in the
It's not a shift in supply.
It doesn't affect it
It's
at all.
it does affect it, but it's the
It's a long end.
it's a long end,
Oh.
yeah.
I don't know.
Because the demand curve shift, this anchored how far that shift went at
So it's-
price staying constant
Right,
as the
okay.
multiplier, and
Okay.
then, yep,
I have that first, and I was like, no, you're okay.
yep. Uh, 112. Did you see how that went? So there was 6,000 workers, 6,000 jobs. They were export jobs. The multiplier is 2. So it's, the number of jobs are gonna go up by 12,000. Yes, it's a 1-to-1. It's a 1-to-1 ratio. Yeah. So that's the one. That's the one little nuance with the multiplier, that you're not multiplying 2 jobs, but each one job supports one other local job. It's a 1-to-1 balance. All right. So there's your 12 then here. Right. So with that shift, that was holding constant the wage. So this is 12. 2 times the multipliers. And so this is the total jobs. It's the one thing that's, you got the 6,000 of the one type, and then that leads to 6,000 of the other local jobs.
Is that right?
Nope.
See,
See, now that's where you were holding back putting that demand curve in. Even though I asked you, just throw the demand curve in. I want to show you
okay.
why this
You're
might
talking about
help a
percent
little bit with
change.
your numbers.
Yeah.
So when this shifts to the
Well-
right, we're at 100, and there's these new
Yeah,
export
yeah,
jobs that are
12%,
brought
sorry.
in, and so that leads to 12. And that, whoops, doesn't have to be perfectly parallel, but there's your 12,000.
Okay. So then you aren't adding in the additional.
That's right,
six.
yeah. So it was 6,000 times 2 is the total jobs added with the multiplier effect. The actual real total is going to be less because the wage is going to go up and the actual amount's going to be less, which is what this is what kind of just mirroring what we did here. This shifted to the right by the total number of jobs, and then it actually ended up being less because wages went up. So we're dissecting those 2 pieces.
And how do we figure out just how many the number of workers?
So then we go back to that formula you were doing here. And yeah, so you've got the 5 and 1 is 6. And
Oh, I don't know.
Except I did it negative, so I put it at 4. Is that wrong at math?
yes.
Okay.
Yes, right.
Yeah,
Absolute
okay.
value. So you're right, it's the elasticity is 1, but it's an absolute value.
So it's always going to be positive.
Right.
Okay. So 100.
So you should end up getting 12%. You should have 12% divided by 6. 12 divided by 6 is 2.
Okay.
Because 12% was the amount of employment. We're calculating the wage change. And the 12,000 came from up here. Okay.
Okay,
So now you got the pieces in.
Yeah.
12 divided by 6 equals 2. So you get a daily increase in the wage of $2. Yep. Yep. Okay. So, any other last questions? It looked like all of you guys got it down. Did you get the 12 and 6? So the first piece of the puzzle, let's just kind of work through it together here just to kind of summarize. Oh, I just had a bigger board. Anyways.
I think you're using your swivel.
No, I'm just playing. Just
Oh,
gonna go
looks-
back and forth.
Looks like he's still on me currently, so that's good. All right, so first step A, we had 6,000 export jobs with a multiplier of 2 leads to 12,000 new jobs in total with a pure multiplier effect, not taking into account the equilibrium effect, which is what we're trying to dissect. So then the percentage change in the wage is the first step of solving that. Ends up being this little nifty formula of the 12% bump in employment divided by the 1 plus 5, which is elasticity of demand and absolute value plus the elasticity of supply. And absolute value gives us the 2% wage bump. So wages are going to climb from 100 up to 102. The elasticity of supply gives us the percentage change in the quantity of labor from a percentage change in the wage. That ends up being, since this was given to us, the elasticity of supply is 5, and the percentage change in labor over the percentage change in wage, which is a 2. 2 times 5 is 10. So there's a 10% bump in the labor, increasing us from 100 to 110 with this particular example. Okay? Swallow it for now. Figure it out more later. All right. So let's end on a good note here. We got a few minutes left here. Why is this thing so kinky? Durable housing and kinked supply. What is it about housing? This one kind of is near and dear to my heart since I was in real estate for such a long time.
Because the number of houses are set and not really easily movable good. Like at that point, splats pretty inelastic.
Okay? So that's in the downward direction. The kink comes about because of the kind of the difference between moving one direction or the other. And I think you got the downward direction correct, right? The supply of housing is relatively fixed. So if demand falls, you kind of got what you got. We're just saying a hypothetical demand, decrease in demand. People hate Chrysler cars, and so they move out of Detroit, right? Now that we're not producing cars, GM, or I should say GM, I guess, decrease in demand. The housing stock is relatively fixed, so there's a big price effect. Now on the flip side, if the car industry is moving forward, generating new houses is different than what's left with old houses because of the nature of the beast, because houses are kind of sticky. Houses might take a little time to build, so we think about new construction. That might move this direction. So the shapes of the supply curve is different in the downward direction versus the upward direction. And so we get this kinky looking supply curve potentially with different elasticities depending on the direction you're heading. Now, this brings up something we've talked about in terms of cost of living and that factoring into the equation. What I think was interesting about this paper is how the wage wasn't the thing that reacted, which kind of makes sense if we start to think about it. So in a declining city versus a growing city, this economist studied both of those places and found that the wage was pretty similar. So the declining city had falling demand, presumably, for wages, but it wasn't that sensitive to it. There was a 2% decrease. But housing took a big hit. So the one that was fixed in supply is the one that absorbed the impact. And so if you're thinking about moving to that city, on the flip side now, if you're moving to a declining city, you're like, woohoo, cheap houses. Well, they're only going to pay you $14.49. Well, that's okay. I can pick up a house for $71,000 as opposed to $112,000. So my real wage, which is what we always focus in on even in macro class and in micro class, the real wage in terms of the purchasing power of your wage is still much greater in the declining city. And so that's the resource that's absorbing the shock, the demand shock of the changes that are going on within the city. Okay? All right, we'll close there and pick it up on Thursday.
Review in the chapter.